Next, modular. For modular, I have one video because this is a special type, not commonly used in actual practice. So let me play a video so that we get the idea about the modular AHU. This is a special type. Again, as per the space consideration or again, as per the site condition, etc. So let me play video. You'll get the information about the modular AHU. And remember, this is a AHU only. Again, the source, the source is required. Means chill water supply is required. You'll find the components inside. Same AHU components, but the arrangement is different. So here, don't get confused. You see, let me start from the beginning. The right side is a supply to the space. Left side is a return from the space. And this is a fresh air. And you see, in the return, partly is supplying back to the coil and partly is going to exhaust. Exhaust equal to the fresh air. Just I'm trying to explain the concept. You see, this is return from the room. This is supply. In the return, some amount, say, same, for example, say 10%. 10% I'm going to exhaust. And 10% I'm going to add the fresh air, for example, that we record a calculation for this. So you see, return air, say 90% and 10% fresh. Then again, it's applying to the cooling coil. You know this concept. And again, this is connected to the chiller. It's a modular. In a compact unit, you'll find all this duct. In space point of view or installation point of view, this is easy compared with the other type. So not commonly used. This is one type. You can suggest as per the project requirement. If there is no separate AHU room, and even you cannot place on the roof, so we have and we can able to manage some space inside, one can use. And this come with a low noise because this we are placing in the conditioned space or close to the conditioned space, so it is available with the low noise. And Daikin is popular in the market, especially for the no or very low noise equipments. Even in Daikin outdoor unit, you'll find very low noise. Next, you see hydronic AHU, nothing but you know this, the AHU which use chill water, DX which use refrigerant, constant, already we discussed this, constant value AHU and variable. The difference is the fan motor. This is with the constant speed, this is with the variable speed. Clean room specific application, this is important. Heat recovery AHU, this is new in the market. New means compared with the other types. And now now in market, we are talking about the green building, saving of energy, etc. So we have two options. One is separate HRU or AHU with the HRU. Separate AHU, HRU we'll discuss. Anyhow, I'll cover in this only, but we have a separate option for HRU also that can be used as a separate unit with the AHU plus HRU as 2 unit, or else we have a combined option now in market that we can call as a heat recovery AHU. Let me show you this. This is important. You see, in this part you can consider as AHU, and this part you can consider as a HRU, heat recovery unit. So what exactly happened in this? You see, the concept of the AHU. For example, this is say supply duct, and here we'll connect the return duct because you can see the filter. So you see return air. Let me show the direction first.
Right side
sorry, this is return. This is return here, and you see in the return after filtration, it will supply to cool air. Again, in that consider say 10% I'm going to exhaust, and 10% exhaust means 10% I'm going to take the fresh air. So you see here you can see the filtration means this is in, this is for fresh air. Just I'm considering 10% as a thumb rule, and that must should be exhaust. So now when you take the fresh air after filtration, it will pass through a wheel, desiccant wheel or a special wheel which will exchange the heat. For example, in summer, the hot air temperature, suppose outside temperature say 40 degrees centigrade. The 40 degrees centigrade air after this filtration will pass through this wheel. This is called desiccant or the recovery wheel. So what will happen? This hot air heat will extract by the wheel, and you see this wheel will run very with the slow speed with a small connected motor. Listen. And this wheel will run with a small motor with a very slow speed. It will turn. So what will happen? The fresh air passes through this, and because of this, the fresh air heat will extract by this wheel, or a heat exchanger.
Okay.
And what will happen? And it will pass and it will supply to this cooling coil. You know the process. But now you see when you with the return air, some air we are going to exhaust now. And remember, in the return air, you will find the temperature of return air is not same as the outside air. Na? For example, return air temperature say 30 degrees centigrade and outside temperature is 40 degree. So when you exhaust, what will happen? The cooling effect which is going to loss with the exhaust is going to what? Extract by this wheel, or it will exchange the heat. So the recovery, that's the reason we used to call it this as a recovery unit or HRU, heat recovery unit. So the return air, so 10% return air is going to exhaust now, and return air is what? The temperature of return air is less than the fresh air now, or in other words, with the exhaust, with the return air, some amount of air we are going to exhaust. So with the exhaust, the cooling is going to loss, means energy is going to loss now. So the energy which is going to loss through this exhaust air is going to recover by this wheel, and this wheel is turning now, it's exchanging it's turning very the slow speed. So the cooling effect which is going to loss through the exhaust is going to exchange to the fresh air, because heat transfer from high temperature to low temperature. You can try to understand with this. First of all, the new components in this is a heat recovery wheel or a chemical wheel, and this wheel will rotate slowly. It will rotate with a small motor connected to this. Okay. So this side is a new. Right side,
Right side.
You see right side you can consider as a AHU.
Normal AHU, normal.
So you see here, so you can consider here. You see, this is a returner, and partly you can consider like this. Some amount of air we are going to exhaust equal to what? Equal to the fresh air. So the air which is going to exhaust will, with the exhaust, the cooling also will loss, right? Because we are not utilizing the complete cooling of the air. Some amount of energy is going to loss with the exhaust air. It can be a cool air in summer or it can be hot air in winter. In both the seasons, there is a loss of energy with the exhaust air. So what will happen when the air before exhaust, it will pass through this wheel, and what will happen? The cooling effect which is going to loss is going to exchange to this wheel, and the exhaust is going to happen. Now in the other side, we are taking the fresh air. Suppose fresh air temperature 40 degrees centigrade, and will pass through the filter, and before supplying to the cooling coil, it will pass through this wheel. So you see this wheel already exchange that or extract that energy, the cooling energy, which is going to
Ah,
supply to the fresh air. So after passing this, suppose the fresh air temperature say 35 degrees centigrade. For example, we have a separate selection for this with the software also. So with this additional HRU, which is connected to the AHU. So if it is connected to the AHU, we can call it this as a heat recovery AHU. In market, you'll find this as a separate unit also, which can be connected with the fresh air and exhaust duct with the normal AHU. But now in actual practice in market, the manufacturer, they're offering AHU with the HRU as a one unit. Okay, so this reason we have this type. In previous years, we have a separate HRU, it's not combined with the AHU. But now in the market, that's the reason in the list of AHU, you'll find this type. Just what is HRU with the heat recovery? That's it. Yes.
if I, in short, if I'm explaining,
Hmm.
in exhaust air, it will give some cooling effect to the wheels, right? And again, when you provide the fresh air from the atmosphere, so when it passes the wheels, so the temperature will get lower for outside temperature.
We are recovering that energy, no, which is going to
So
loss
so
through
it's
exhaust.
so it's an advantage. So where lower the temperature of fresh air, so it's an advantage. So it will be less load to the evaporative
You see,
evaporative coil.
we did one project 5 years back. No, sorry,
Mm-hmm.
7 years back, and we achieved 30% saving overall. And so it was a big project, and
Mm-hmm.
37% saving means the saving of energy in that is a considerable. At that time, it was new in India, but it's a part of a green building. And if you are dealing with the
Yes.
green building, you see,
Mm-hmm.
previous year it is used with the green building. Now it's common for almost all the project or for all big projects. I'm talking about big
Okay.
project, not for small project. So this also a type of AHU. But don't worry, we have a separate concept for HRU. That's the reason I've not. Next, you see,
Concept is
we have a FAHU. The same AHU, if I use for fresh air, that I can call as a FAHU. Let me show you some images. For example, you see, this is only FAHU. This is not a recovery unit. In this image, this unit, you can see the filter. There is no return duct. It means this is used to suck complete fresh air. On other side, you'll find the supply duct, which will supply the fresh air to the multiple spaces inside the building as per the fresh air requirement. Or else you can find this image. You see, in this you can find the supply duct, and you see at the back side there is only a coil piece. There is no return duct. So this unit is used to suck complete fresh air as per the building requirement, and it not mean that this duct will supply to one space. This duct is used to supply the fresh air requirement for multiple spaces. So you see, for example, consider a floor, and in the previous session we discussed VRF system. So assume that one outdoor, and this outdoor is connected to say cassette 1, cassette 2, cassette 3, cassette 4, and there are say 4 spaces. So in this, how we can provide the fresh air? By using a separate FAHU. So we are placing a separate unit, and this can be connected to the chiller, or this can be connected to the condensing unit. It can be DX system or chill water system. And with the duct, we are providing the fresh air. You see, and main duct, after main duct, one branch to this, one branch to this, one branch to this. Only the required fresh air this FAHU will provide, not the total CFM. The complete CFM is going to take care by this what cassette or cassette. In this example, it can be AHU or FCU. But the fresh air requirement for this spaces, we are providing with a separate unit. And in that case, this unit we can call as a FAHU, fresh air handling unit. And this FAHU we are going to select based on the requirement of the fresher of the spaces, not for the total CFM of all the spaces. For example, space 1, 500 CFM fresher is required. Space 2, 200 CFM is required. Space 3, again 500. Space 4, say 300. Okay. So we'll select this FAHU summation of all this fresh CFM only. The total CFM of this room, say 3000, for example, out of which say 10% means say 300. Now, for example, just percentage I'm using just like a thumb rule. We have a separate calculation for this. So this FAH is responsible to provide the requirement of fresh air. And FAHU means AHU, in that you'll find the cooling coil. Definitely is going to be a treated one, means the cool
Mm-hmm.
fresh air,
Mm-hmm.
right? So the same FAHU, if I use to provide the fresh air, and there is
Mm-hmm.
if there is no return duct,
Mm-hmm.
that unit we used to call as FAHU, and this can be a hydronic FAHU, or it can be a DX FAHU. DX means connected with the condensing unit. Hydronic means connected to the chiller. The source of the cooling may vary, but the concept is going to be same. This is used to provide the requirement of only fresh air. The remaining total CFM will take we're considering as per the required system. And this is also known as TFU, treated fresh unit. And since we are placing completely outside, so this must be what? Double skin. And if you're using in India, simply we are connecting a piece of a coil piece like this. But if you're using this in Gulf, we require a sand trap lowers. Sand trap lowers. Here at the suction site, this picture is taken, belongs to this project in Hyderabad, meaning India. So this you can find the filter. But if this project belongs to Gulf, so you can find a sand trap lowers here. The purpose of sand trap lower is to what? Trap the sand, because in Gulf area commonly you'll find the sandstorms, no? So if in at the time of sandstorm, if you not use the sand trap lower, the complete filter will block. Okay, and what is sand trap lower? We'll discuss at the time of air side. At this level, the sand trap lower is used to trap the sand at the suction side, which we are placing, which is connected to the outdoor unit. Sorry, which is connected to the FAHU. Got the idea online about FAHU?
So we have covered the hydronic, DX, constant volume, and
Ajay in the class.
yes, he's in the class.
So this was about the different types of AHU. And you see this AHU, as we discussed at the beginning, is for higher capacity compared with the FCU. So for big projects, you'll find this AHU in a separate AHU room, or it can be a ceiling suspended as per the capacity to serve multiple spaces as per the requirement. I'll show you one drawing in that also. I'll try to confirm this example of FAHU, AHU, and this different FCU. Now, at this level, you may not able to read this completely. Just try to visualize. In this project, you see this unit. This unit, you can find the tag also, FCUA, and the number is 28. So this is what? Ducted FCU. And you see, use only for this space, no, not for the complete area. The limited capacity. So this unit we can call as a ducted FCU, ceiling suspended type. This also same. Beside also you'll find one more FCU. Now, you see, this look like a package, na, as we discussed in the previous. But in package, you'll find the condensing unit also. So there is no
Yes.
condensing unit. So this is AHU. You can find the supply duct as well as return duct. And remember, supply means with the two diagonal line, return with the one diagonal line. This is a representation for supply and return. At the time of ducting, we'll discuss. At this level, just confirm this AHU. So in this project, you'll find one AHU here. You'll find chiller also, that we'll discuss later. And you see, in this rooms, you'll find what? High wall FCUs. This is actually a hotel project. So in this hotel rooms, in this area, you'll find high wall, and in the open area, you'll find ducted FCUs with false ceiling. These are all diffusers. And in these rooms also, you'll find all high wall FCUs. You see, these are all high wall FCUs. Let me open the other floor of the same project.
What are those, sir? Green ducts?
That is for exhaust actually. That is for toilet exhaust. Let me open the other floor of the same project. You will find the concealed FCUs also in this. Here is a hotel room. And you see this concealed FCU, this one. And you see it's a piece of a duct. It's not complete ducting, piece of duct. And you will find the grill. And this is above the false ceiling. You will find the conceal. And this white color box is a return air plenum, and to which you can find this cyan color lines. This is used for supplying the fresh air. supplying the fresh air from the blower, which we are play, which we sorry, from the exhaust, from the say normal fan, not FAHU, to this box. In this case, the heat of the fresh air is going to bear by this unit. If you're using separate FAHU, in the load calculation, we are not considering the heat of the fresh air but, at the time of considering this unit. This is also important point. We'll discuss at the time of load calculation. At this level, if
Normal,
you're not getting, ignore this.
no,
Hmm.
normal fresh air to be added, right?
Yes. And you see this. Okay, I'll show you the exhaust fan also. Okay, anyhow, you'll get the confusion. I'll not show this level. Just verify the units only. These are the conceal FCUs. You
Mm.
can find the accuracy FCU as well as the AHU. See, this is also FCU. Just to confirm the units only. Other details ignore at this level. You may not get, because we have not discussed anything about this air side, ducting side. Okay, so this was about FCU and AHU. Now the summary. You see what I explained the same. SU can be a decorative type or conceal. You know this. Decorative also you know. Conceal also you know. And AHU can be a ceiling suspended or a floor mounted ceiling suspended up to 15 TR commonly, critically up to 25, but in actual fact is most commonly up to 15 TR. Above that you'll find floor mounted up to 250 TR. Next, fan motor is directly connected to the, sorry, fan motor shaft directly connected to the blower, but in case of AHU with the belt and pulley, you know the reason what we discussed. An FCU is a direct throw, no use of duct except ducted FCU. Generally, ducting means you'll find the higher capacity with the AHU. So generally in actual practice, FCU means we are not talking about the ducting side. FCU is simple, AHU is more complex, you know. And FCU, there is no option for fresh air in FCU except some models. Concealed FCU, we can provide the fresh air as we discussed in this just now. You see in the concealed FCU, we can provide the fresh air. If it is a decorative FCU, there is no option to provide the fresh air. But in AHU, one can provide the fresh air to the suction. And you see, in the previous sessions, we talk about the ductable split. And you know
Mm.
how to provide the fresh air to the ductable split at the suction by using the coil piece. And that
Yes.
unit we can consider as AHU. No? An AHU generally conceal above the false ceiling or in a separate room. So we can easily provide the fresh air. You see, I'm not talking about FAHU. We can provide the fresh air to the suction of the AHU. It can be ceiling suspended or it can be floor mounted. Or else we can provide the fresh air with the separate FAHU or FAHU with the HRU. Okay, so remember all this. We'll discuss in detail in the future classes. This terminology, what we're discussing, this type is very, very important. Repeatedly, we are going to use these terms and terminology till the end. Next. So what I explained the same summary. Next, we have one more important topic, DX and chill water. So I think you got some idea about this topic because in between we discussed, no, DX means what? Refrigeration system. Chill water means what? Chill water system. But still, we have not discussed in detail what is chill water system. So in interview, this question may ask the difference between the DX and chill water system. Okay, so this topic we'll discuss in the next session. So in the next session, I'll complete this chapter with a very, very important topic, air cooled and water cooled chiller. This radiant cooling and district cooling concept is simple, but the important in detail we'll discuss about chill water system because as per syllabus in part 5, we have a separate chill water pipe sizing, okay, for chill water system. And if you know chill water system, then district cooling system is similar to that, only the plant is away from the building. And radiant cooling is not commonly used. This also one type. So I add in the syllabus. Okay, so in the next session, inshallah, I'll try to complete all this.